Welcome everyone. In this lecture I will discuss solving differential equations of this form, as you can see on the screen, where the derivative of y with respect to x is a function of a of x plus b of y plus c, and we will use the substitution method that was discussed in my previous video. So let's begin. Well, I will start with the definition of function. A function relates an input to the output. I've drawn an illustration over here. As you can see that this box basically represents a function f of x, a function that depends on the variable x. And to this box we are giving some input, which is basically x. When you give this input to this system, which we call as a function, it will result into a certain output that we call as y mostly. So this is a function. We can relate an output to the input. Now, as I was saying that f of x is a function that depends on x for its output. Now f of x can be equal to a number of different expressions, like here I have shown that f of x is equal to x cubed plus 5. Now whenever I will give an input to this box, that is x, some values of x I will supply to it, and based on those values of x, f of x will compute the output. So let's say I have given as an input x is equal to 1 to this function. It will compute 1 cubed plus 5 and it will result into 6. Likewise, as you can see over here, we can have f of x is equal to cos of x. So we have different functions, all those functions based on x, but we have different expressions in front of them. We can have under root of x, cubic root. Now here I have shown that if I replace x with a of x plus b, that now this time my function depends on a of x plus b. So this means that this system depends on the input a of x plus b, because based on that it will compute this expression that is written on the right hand side, that is ax plus b whole cube plus 5. So as an input you will supply a of x plus b, and based on that it will compute the output. The next example is shown over here. F of ax plus b is equal to ax plus b whole cube divided by a of x plus b plus 9. So it is a different variation of the function, and we will get different results if we give different values of a of x plus b, where b is a constant and a is a coefficient of x. The topic of this lecture is that if we come across differential equations that are of this form, like we have differential equations which are equal to functions of a of x plus by plus c, then there is a certain procedure that can be used to solve such type of differential equations, and for that you can make use of the substitution method. The substitution method was discussed in detail in my previous lecture, and now we will make use of the same substitution method to solve such type of differential equations. But before solving such equations, we need to make sure that the b over here is not equal to 0, and after making sure that, we can make the substitution u is equal to a of x plus by plus c. Afterwards we can simply separate the variables, because the equation will get reduced to a form that can be solved using separation of variables. and which will require integration, and we can compute the answer simply. So now I will do some examples to clarify these concepts further. Overall solution of this question, but I will discuss step by step. Now, as you can see, we are given with this question dy by dx is equal to tan square x plus y. Well, as you can see that in this equation we have this x plus y over here. Now if you relate this with the function that was given to us, it was that if differential equations of the form where the function is equal to a of x, now look over here, that a of x, we have 1 of x over here, then the function says plus b of y, so we have 1 of y over here, and the last term of that equation was plus c, so over here we have c is equal to 0. So we can easily relate this differential equation with the form that was given in the first slide of the lecture. So we have this differential equation with us, and we can easily make use of the substitution method to solve this differential equation. Now what I will do over here, I will replace this part x plus y with u. I will suppose that u is equal to x plus y, and because I have to make substitutions in this equation a that I have labeled as a, I need to take the derivative of this as well, because I have to replace this dy by dx as well. So taking the derivative of this u is equal to x plus y, I will get this, rearrange this equation, and you will get dy by dx is equal to du by dx minus 1. Now I will substitute this dy by dx and this u in this equation a, and you will get du by dx minus 1 is equal to tan square u. Now just bring this minus 1 from here to here, and you will get tan square u plus 1. Now if you remember this identity we have, tan square u plus 1 is equal to secant square u. We will substitute this secant square u in the above equation to simplify this equation further. So I will get du by dx is equal to secant square u, and now because of this substitution, I am now into this situation where I have this form of equation which can be solved using separation of variables. But just to make sure that I can further simplify it, so let's see that this now because we will get 1 over secant square u. If we try to separate it, we will get on the left hand side 1 over secant square u into du, and on the right hand side I'm getting dx. Now as you know that secant square u is equal to 1 over cos square u, and this is ultimately equal to cos square u, and this cos square u as you know the identity of cos square u, which is equal to 1 by 2 into 1 plus cos 2 of u. I will just substitute this identity over here, and now I will solve this equation further. So as you can see that I have also taken integral over here, because when you separate the variables, as you remember from the separation of variables method, that after separating the variables you take the integral on both sides to solve that equation. So here I have also done that first I separated them, the u part on the left hand side and the x part on the right hand side, and after just putting the identities, now I have taken the integral on both sides, and once you have taken the integral on both sides, you will get u by 2 plus sine of 2u by 4 is equal to x plus c. Just further simplify it, and now as you can see that we are getting in denominator I'm getting 4, so move it over here and you will get 4x plus 4c. Now This 4c is a constant. As you know that c is a constant, and when it is multiplied with 4, when we multiply the c with 4, you will get another constant. 4 into c is equal to capital C, so I'm getting another constant, so just replace it with capital C. Now once I'm done with this and I cannot further solve this question, so now substitute back. We were supposing u is equal to x plus y, so I will substitute this back into the equation 3 and I will get this answer. So here is the next question, and it's an initial value problem because an initial condition is also given to us. So let's start. As you can see that in this differential equation, how you can relate this one with the equation on the first slide where the form was given. Well, this form was given to us that if dy by dx is equal to a function of a of x plus by plus c, then we can suppose u is equal to ax plus by plus c. Well, if you look into the denominator of this equation, we can substitute u is equal to 3x plus 2y plus 2, where a is equal to 3, b is equal to 2, c is equal to 2. Now after doing that, what we will do is we will take the derivative of this u with respect to x, and we will get du by dx is equal to 3 plus 2 dy by dx, and just rearrange the equation because we have to make all these substitutions in equation A. And if you look into the equation A, we have also this 3x plus 2y. You can easily substitute this 3x plus 2y by u minus 2. If you look into this equation B, it says that u is equal to 3x plus 2y plus 2. So this can be rearranged and you will get u minus 2 is equal to 3x plus 2y. So I will make all these substitutions in equation A. After making all these substitutions in A, I will get du by dx is equal to 5u minus 4. Now we can easily separate these two variables u and x, and as you can see that on the left hand side I will get u by 5u minus 4 into du, and on the right hand side I will get dx. Now there are different ways to solve or simplify this left hand side, and what I have done over here is that I have just multiplied and divided this equation with 5 to get 5u. All I am trying to do is to create 5u minus 4 that is in the denominator to also appear on the numerator, so that this equation will get further simplified. So after doing that, I'm just adding and subtracting 4 in the numerator, and as you can see that I will get 5u minus 4 plus 4 in the numerator. So I can now write it this way, and in this way this part will get cancelled and I will get 1. Now I can take the integral on both the sides because the equation is not only separated one, it is also now the simplified one. So I can take the integral on both sides, and as you know that the integral of 1 dot du will result into u, and this integral, that is the integral of 1 by 5u minus 4, will result into natural log of 5u minus 4 divided by 5. And how this 5 has come, as you know that you have to take the derivative of this part and divide it by that derivative. Now this is equal to x plus c. Once you can, as you can see that now you cannot simplify it further. So what I will see this substitution that I made, that was u is equal to 3x plus 2y plus 2. I will put back into this equation D, and now this is the general solution. Now, because the question was an initial value problem, now I will suggest you to further solve this question. I'm just telling you the steps that are required to do that. What you will do is, because as you can see that y of minus 1 is equal to minus 1 is given to us. This means that when you put value x is equal to minus 1 into this function, you will get y is equal to minus 1. So this means that x is equal to minus 1 and y is equal to minus 1. So I will substitute x and y values in this whole equation, and afterwards the only unknown thing in this equation will be c. So because everything is substituted, I can easily find out the value of c, and I will suggest you all to find out this answer and post it below the video. Now here is another question, and my question is that how to solve this type of question. dy by dx minus x square minus 8xy is equal to 16y square. Well, think about it whether this question can be solved using the method that we have learned in this lecture or not. Give your answers below the video. Thank you.